we are going to look at Lagrange multipliers here. The function I want to talk about is, the question is, minimize f of xy is equal to x squared plus y squared, subject to the constraint x plus 2y equals 4. All right, so the idea here is we have this x squared plus y squared. This is my function x squared plus y squared. It's your paraboloid. It doesn't have a minimum. But once you constrain it, well, it has a minimum, it's at 0, 0. But once you constrain it to another function, x plus 2y equals 4, you notice that there is a minimum to the paraboloid subject to this green constraint, x plus 2y equals 4. And so our goal is to show that this point right here is the point. Okay? With Lagrange multipliers, the way you work this is we're going to let the left-hand side be g of xy. The gradient of f is equal to lambda the gradient of g. We do some work, work, and we end up with the minimum being 0.8, 1.6, and 3.2. That there is the point that is on this graph right here. Notice it's 1.8, 1.6, 3.2. That's that point right there. Now, when you look at Lagrange multipliers, the basic premise is that the gradient of the function we're trying to find the minimum of is equal to some constant lambda times the gradient of g. This means then, another way to look at this is to consider, here is the green g of xy, and then all of the possible contour lines of the paraboloid are here in orange. So my paraboloid is in orange, my constraint is in green here. And so the first one that is tangent, the first contour line here that is tangent to the constraint is going to be giving you the point that is the minimum. Okay? And so if we make this is 4, here we'll make that a 4. If I move, let me show you. See, these are all the contour lines of f right here. If you look over here, the one that stops at 3.2 is the exact one I need. Why 3.2? Because that is where x squared plus y squared equals 3.2. That is that point here, which is 3.2 there. So when we're at that height, 3.2, we have the minimum. And what I've done here is I have shown that moving as it goes up and down, you'll see how these are the contour lines of the paraboloid, and once we hit 3.2, we're where we need to be. So I'll do a second video to show you what I did with all this here. I made a folder, and I'll show you how to do that to organize the work.